In this video, we're going to evaluate permutations and combinations. I'm going to show you both the formula for them. The NPR is equal to n factorial over r factorial, and the NCR is equal to n factorial over r factorial times n minus r factorial. Thankfully, I don't have to compute these by hand here. I can just go ahead and use a feature that's in the calculator. So I'm going to put in the 52 first. I'm going to go into my math menu, arrow over to PRB for probability. And there's my NPR. And it understands that 52 to be the first number that 54 is what that is. Let me go back and change that. 54. Choose 2 where order matters. So yes, there we go. 54P2 is going to be 2862. And so it performed this calculation for me without my needing to calculate any of that. So permutations are when order matters. Combinations are when order doesn't matter, like committees and things like that. All the same, everyone's equal on the committee. They're just a committee person. P is going to be, maybe you have a committee, but you're choosing people, who's going to be the president, who's going to be the vice president, and so on. And the order in which you choose the people matters what rank they have on the committee or what role they have. Let's go ahead and let's try 38, and then math, arrow over to probability here. And we're going to do NCR, C for combination. And we're going to choose 2. And we see that there's 703. This gets to the thing that I was talking about before with the dice, of whether it's distinguishable with the 2 dice. Are they the same color? And I can't tell the difference between 1 and 2, and 2 and 1, or are they distinguishable? Can I tell the difference between the red die and the green die? And I said that would be something we would be getting to later. This was what I was referring to, was the difference between permutations and combinations. That if we have indistinguishable die, that we're really talking about a combination situation with a much smaller number of possible outcomes. If we have a distinguishable dice, we have a permutation situation where order matters, where we can tell which one's red, which one's green, and we have many more possible outcomes. So your teacher will give you some more examples like that in class, I'm sure, but watch out for, especially in dice problems, if the dice are distinguishable or not distinguishable from one another, because it's going to matter whether you're going to use a permutation or combination to figure out your total number of possible outcomes in your sample space. All right, that's it. And we're going to go ahead and come back and talk more about 3.4 in our next video. See you for the next video.